In this video, we're going to identify the x and y intercepts of a quadratic function that is written in vertex form, and we're going to do so algebraically. So using algebra to find our x and y intercepts really comes into play in one of two situations. One, it's that we can see the x and y intercepts on a graph, but they aren't nice integer points. When they're nice integer points, they're normally points we can find in a table, we can see them really clearly. And when we don't have nice integer points, it means we're going to have to figure out what the decimal value or the rational value is. The other option is that we don't have a graph at all. So we're being asked to find x and y intercepts, but we don't have a graph of the function, so we can't even visually see it. So those are the two situations where we're really going to utilize this strategy. So from here, in order to find our y-intercept point, what we need to do is we need to think about what we know about the y-intercept. Well, I know the y-intercept is a coordinate, and I know that it's a coordinate where x is equal to 0. So if you remember, the y-intercept is where the graph crosses the y-axis, and all of those points along the y-axis have x values of 0. So what we can do here is we can substitute 0 in for x into this particular equation, and we can find the y value that goes along with it. So here I notice that I would have y is equal to 6 times x minus 4. Well, I'm replacing x with 0 here, so I'm going to write 0 in there. So 0 minus 4, quantity squared, minus 216. So if I'm going to solve for y, what I need to do is I need to use my order of operations here to simplify the right-hand side of this equation. Because I have the variable isolated on the left, I need to use my order of operations here. So what I do is I look and I say, okay, well, I always start with parentheses, and 0 minus 4 is negative 4. So in order to simplify this, I would have 6 times negative 4 quantity squared minus 216. Well, then from here, I know that negative 4 squared is 16, so I have 6 times 16 minus 216. Now from here, I need to use my multiplication, so 6 times 16 is 96. And then finally, I end with subtraction, and that gives me a y-intercept of negative 120. So just from substituting 0 in place of x, I'm able to find that my y-intercept point occurs when x is 0 and y is negative 120. So now let's flip this around. Let's look for our x-intercepts. And in order to find x-intercepts, we need to find the point or points where our graph crosses the x-axis. And so we know that these are coordinate points, and what we know about these points is that they are the x values when y is equal to 0. So we cross the x-axis when y is equal to 0. So what we're going to do here is we're going to set 0 equal to, because y is now equal to 0, 6 times x minus 4 quantity squared minus 216. Now unfortunately this one isn't quite as simple as the last one. The last one we just had to simplify the right-hand side of the equation. On this particular problem, we actually need to solve for x, which is snuck inside of this equation. So essentially what we're going to have to do is we're going to have to get this part with x, this part that is squared, completely by itself. And what I'm thinking is, because I notice that I have just one x in the problem and it's inside of something being squared, is that I'm going to use my square root strategy for solving quadratics, because I think if I can get that squared piece alone, I will be able to undo that squared by square rooting, and then I'll be able to isolate x and determine what x is equal to. So to start, I need to move the 216, so I'm going to add 216 to each side. Then from here, I need to get the piece that is squared alone. I can't distribute inside of here because of the squared here. That squared makes things a little more complicated, so we divide each side by 6. So 216 divided by 6 is 36. Now to undo that squared, I can use the square root strategy, so I can square root both sides. But what I need to keep in mind is that there are two numbers that when squared give me 36. So when I square root 36, I end up with 6. So what I know is that there are two options. There's x minus 4 could equal a positive 6, or x minus 4 could equal a negative 6. Because remember, 6 or negative 6 when squared give me 36. So either one of those situations would make this equation true. If I have x minus 4 is 6 or x minus 4 is a negative 6. So if I add 4 to each side of each of these mini equations, I find an x value of 10 and an x value of negative 2. And basically what these are telling me are that if I take these x values and substitute them back in here, and then subtract 4 from them and square them, I will get 36, which I know is true. 10 minus 4 is 6, 6 squared is 36, negative 2 minus 4 is negative 6, and negative 6 squared is 36. So I've found my two x-intercepts. Now I need to always end by writing my x-intercepts as coordinate points. So these are going to occur when x is 10, y is 0, and x is negative 2, y is 0. So I can start to visualize this graph. The x-intercepts are where it crosses the x-axis. There are two locations where that happens, and then I have the point where it crosses the y-axis as well. So let's practice this process just one more time. So here we have our y-intercept, and remember our y-intercept occurs when x is equal to 0. So the simplest way to find our y-intercept is to take our equation here and to substitute 0 in for x. We have 0 plus 2 quantity squared plus 85. Now remember, because we have the variable already isolated by itself, all we need to do here is use our order of operations in order to simplify this further. So we're going to start by using the parentheses, because in order of operations, parentheses comes first. So we have negative 5 times 2, because 0 plus 2 is 2, squared. Then from here we would do our exponents, so that's 2 squared, which is 4, so I have negative 5 times 4 plus 85. Well, negative 5 times 4 is negative 20, and those added together leave me with 65. So my y-intercept point occurs when x is 0 and y is 65. So now let's flip this around and search for our x-intercepts. And remember, our x-intercepts occur when we cross the x-axis, and these occur when y is equal to 0. So we have 0 is equal to negative 5 times x plus 2 quantity squared plus 85. And because x is snuck over here on the right-hand side inside of the equation, we essentially need to undo what's happening to x to get x by itself and to solve the equation. So from here, I notice that x is trapped inside of a squared, so I'm going to need to do some work here, as I can't really remove x from that squared, nor can I distribute in there. So essentially I need to get this whole squared piece by itself in order to undo the squared and find my value for x. So I'm going to start by subtracting the 85 from each side. So I have negative 85 is equal to negative 5 times x plus 2 quantity squared. I now can divide both sides by negative 5. So I end up with 17 is equal to x plus 2 quantity squared. Now from here, because I have the piece that is squared by itself, I can undo that with a square root. So if I square root 17, I know that the possibilities for square root of 17 are 4.12, and then because I need to find what squared gives me 17, I know that negative 4.12 when squared could also give me 17. So what I can do here is I'm noting that there's going to be two values for x here, because there are two values that when squared result in 17. And we can find those by creating two little mini equations. So we have x plus 2 could possibly equal 4.12, and x plus 2 could possibly equal a negative 4.12. So that's what could happen here. If x plus 2, whatever that is equal to 4.12 or negative 4.12 when squared, it will produce 17. So now let's subtract 2 from each side. We end up with an x value that is equal to 2.12 or an x value that is equal to negative 6.12. So I have two possible values for x here, and as a result I can now write my two coordinate points for my x-intercepts. I have the point when x is 2.12, 0, and the point where x is negative 6.12 and y is 0. So I have two x-intercept points along with one y-intercept point.